So then I give you, this is the Math Models first semester exam review. This is part 1. Question 1. Scores on the Unit 1 exam are listed below. What's the probability that a student picked at random scores 75 or above? So if they're going to score a 75 or above, we need to figure out how many of these score a 75 or above. So we have an 83, we have a 90, 2 90s, an 80. All of these are 75 or above. So how many is that? Okay, so 8 out of how many total? So 8 out of 15 scored a 75 or above. So if I had put all those people in a hat and mixed it up and I randomly drew one, then my probability of picking someone that scored a 75 or above would be 8 out of 15. Now if you want to change that to a probability can be written as a fraction or as a decimal. So we could put that in the calculator and get the decimal equivalent if we wanted to, which would be 0.533 or 0.53 repeating. All right. Number 2, a manager of a sporting goods store was analyzing a frequency table, identifying the number of shoes sold during the last 6 months. Which measure of data describes the most popular shoe sold? The most popular shoe sold would be the one that that is sold the most often. Mode is most often. Number 3, Frank rolled a die 7 times and recorded his results in the tally chart below. What is the experimental probability of rolling a 2? So experimental probability is equal to the ratio of the number of times it actually occurred. So how many times did we roll a 2? Correct. 0 out of how many? Doesn't really matter, but looks like 7. So your probability of rolling a 2 based on the experiment is 0. So number 4, based on the tally chart in problem 3, what is the experimental probability of rolling a 5? 3 out of 7. Let's try again. 3 out of 7. Okay. So we can leave it as 3 out of 7. We can write it as a decimal. What would be the decimal equivalent of 3 over 7? So as a decimal, it would be 0.43. Which one is more accurate? The fraction is more accurate. So we had to cut off some stuff off of the 0.43. So it wasn't, we had to round. All right, define the median of a list of data. What's the definition of a median? Middle. When? It's not always the middle. Sort of. The numbers have to be what? They have to be arranged in order. Middle, when they are in order. Now there is a middle when there's an odd number. When there's an odd number of items, the middle is easy to find. When there's an even number of items, you have 2 that are in the middle. So when you have an even number of items, you take the average of the 2 middle items. All right, number 6. For the information in the table below, circle the correlation between the elbow hand length and the height in centimeters of the high school students. Okay, so if we wanted to graph it, we could graph it just to make sure. Hand length is going to go on our x's. Hand length will be our x values, and height will be our y values. So if our range is 35 to 25. Okay, so if we can go, or 25 to 35, we could do something like that, 25, 30, 35. We could even go by twos, or we could, go by ones, 26, 27, 28, 29, 31, 32, 33, 34. On the y value, we got to go from 97 to 139. So we might go from 95 maybe to 140. That'll give us enough room. So from 95 to 140. So space them out evenly so that you can get an accurate, or as accurate a graph as you can. 25, 97. So we got our first point right here, 25, 97. Second point would be 28, 111. So 25, 26, 27, 28, 111. Be about right there. Maybe a little higher. 30, 120. 30, 120. Be about right there. And then 35, 139. Be about right. Maybe right there. So yeah, it's positive. Okay, it's positive. These were increasing. These were increasing. So if both items are increasing, then you're going to have a positive relationship. Okay, now we have a word bank, negative, positive, 0, and undefined. Well, let's do positive. We just did a positive one. What is positive going to look like? Very good. Positive. Time out. All right, so this one was positive. Okay. Negative, be going downhill, left to right. Which one's 0? 7. That leaves undefined here. Which pair of variables is most likely to follow the scatter plot? The amount of calories burned and the person's height. Probably not. Okay. The amount of calories burned and the amount of time resting after a run, we think. Probably not. The more you rest, less. Amount of calories spent, C, and the time spent exercising. Well, C and D are kind of the same. The amount of time spent exercising or the time spent sleeping. It kind of depends. If this is in minutes, okay, if this is in minutes, then after 6 minutes of exercising, I might expect to burn about 80 calories. Sleeping, probably not. But if this is in hours, then after you're burning calories all the time anyway. So if this is in hours, then after 6 hours of sleeping, I might have burned 80 calories. So, I'm not eating while I'm sleeping, so it could be either one. I'm going to go with exercising because I don't think they would have thought that far into it about sleeping. The most logical answer would be exercising, and this being in minutes. All right, quadratic. I like that one for quadratic. So 10 quadratic, or is that 12? That's 12. 12 is quadratic. What's 13? Go with positive on this one. Probably follows it's kind of a weak positive, but we'll go with positive. And And then, yeah, I can't tell if this is going down or up, or if it's straight. I can't tell. So no correlation. "16. Mrs. Williamson asked each of her students what color car they drove. The results are recorded in the table below. What is the central angle of the sector that represents the black cars?" What is the central angle? I'm thinking they're talking about the measure of the central angle. Okay, y'all, I don't know if y'all have done this, and I don't know that, to me, this sounds like a pie chart. Okay? And one of those slivers of the pie represents black. And that sliver, there's 18 black. And that means 18 out of how many total do we have? How many total cars were there? So if there's 18 out of 90, what percent is that? Type 18 divided by 90, what do you get? 0.2 even? Okay, so 0.2, which is 20%. So basically 20% of the cars are black. Now, if you're looking for the angle, the central angle, 20% of the circle should be represent the black cars. And how many degrees are there in a circle? 360 degrees. So this little sector of that circle should be 20%, which is what? 20% of 360, or 0.2. 72? 72 degrees. I'm thinking that's what they're looking for. 72 degrees.